Okay, in this video, we will continue looking at alkanes and their nomenclature, and we'll look at what's called a cyclic alkane. And a cyclic molecule is any molecule that's a carbon connection with no obvious start or end. So you can see here that I have these ring structures. We call this a ring or a cyclic structure, and there's really no obvious start or end. But remember, it's line angles, so each of the endpoints is a carbon. So here, this is a 1, 2, 3, 4, 5, a 6 carbon cyclic structure. This here is a 1, 2, 3, 4 carbon cyclic structure. And this here is a 5 carbon cyclic structure. Now, if I was going to name these as a parent chain name, normally we would just call a 6 carbon chain hexane, a 5 carbon chain pentane, and a 4 carbon chain butane. However, because these are in a ring, we add a prefix in the beginning of cyclo. So this molecule here being cyclopentane, this here cyclobutane, and this cyclohexane. Hexane means it's 6 carbons, cyclo means it's 6 carbons in a ring structure. So the cyclo prefix is added for any molecules that are cyclic in nature. Now, one other rule that I will note here that's a little bit different for naming cyclic structures is, actually I'm going to use black, the parent chain can be the ring itself, or an attachment. So let's look at the example I have here. I have a 6 carbon ring, we can see here, and then I have some substituents coming off. Now, what I mean about the ring can be the parent chain itself or an attachment is if you have an attachment that has more carbons than the ring itself, that would be the parent chain name. In this case, this carbon here is forced into this ring by nature. So you can't really start here as the parent chain name because this carbon is automatically part of the ring. But if some cases you'll have attachments that are longer carbons, and then that itself can be the parent chain. But here we can't really do anything else but name this as the parent chain because this carbon here is forced into the ring. We can't, once again, kind of start here and then add this into the ring. It doesn't work like that. So here this is forced into the ring. So this would be our parent chain, so the ring itself. So this is hexane. But more specifically, because it's in a ring, it would be cyclohexane. 6 carbon ring. So the next thing we'll want to do is identify our substituents. So we have one substituent here and one here. They're both coming off of the same carbon. We know we call a 1 carbon substituent a methyl group. There's just 1 carbon here in the substituent. Remember, this carbon doesn't count when naming the substituent. And this here would be a 3 carbon substituent or a propyl group. So we've kind of continued our same naming kind of, ways, what we would do with a straight chain molecule. The next step would be to number the chain or number the ring in this case. But here it doesn't matter if you number it going clockwise or counterclockwise because it's all attached to 1 carbon. So if I was to go 1, 2, 3 this way, or 1, 2, 3 this way, it doesn't matter because all the substituents are in one single position. So I will just arbitrarily start here and number 1, 2, 3, 4, 5, 6. So like I said, in this case, all the substituents are on 1 carbon. So this would be, and remember we go in alphabetical order, so methyl comes first. So 1-methyl, then 1-propyl cyclohexane. So we follow that same naming structure. We have the first substituent in alphabetical order, the second, and then we attach the substituent name with the parent chain name, this being cyclohexane because the cyclo means it's a 6 carbon ring. So if we break this name down a little bit, this tells us we have a methyl at position 1. This tells us we have a propyl also at position 1. And this telling us it's a 6-carbon, but not chain, a 6-carbon ring, because we have the cyclo here, which would indicate that it's a ring and not just a straight chain. So that's the only difference when you see this ring kind of structure, a cyclic structure. There's no major difference. You just have to add the prefix of cyclo to indicate it's a ring. And depending on where the substituents are, let's say I had a substituent coming off of here, that's when the numbering would matter. So just as an arbitrary example here, to demonstrate this concept, first, I would want to identify the parent chain of this molecule. So here I have a 5-carbon ring, so I would name this as the parent chain. So this is 5 carbons here, so this would be cyclopentane. So the cyclo meaning it's a ring structure, pentane meaning it's 5 carbons. I would now identify the carbon substituents. So I have a substituent here and a substituent here. This substituent we've seen a couple times. This is a methyl group. It's a 1-carbon substituent. And I'm not sure if we saw this guy yet, but this is a ethyl group, a 2-carbon substituent. So this carbon and then 2 carbons here. Remember, the parent chain carbon doesn't count for naming the substituent. So now the question becomes, how would I want to number this chain, or rather this cyclic structure? Because, you know, it does matter which direction I name it. Would I give priority to the methyl group here? Would I give priority to the ethyl group here and make that number 1? And then which way would I go correspondingly? So you do want to number with the substituent having the lowest numbers possible. And where do I want to start with my numbering? Do I want to start with the ethyl, or do I want to start with the methyl? And in this case, you want to go in alphabetical order. So E comes before M, so I would make the ethyl carbon number 1. Now, would I want to go to the left here, or would I want to go to the right? And I would want to go to the right, because in this case, I will encounter the methyl substituent at position 3 versus position 1, 2, 3, 4. So that kind of numbers the chain or the cyclic structure, so the substituents have the lowest number. So I'll continue numbering this way, and now I'll put the pieces together. So the ethyl will come first, so it would be 1-ethyl -3-methyl cyclopentane. Kind of ran out of room there. So we put the ethyl as number 1 because E comes before M, so that would have priority, just like it does in the naming. And we numbered it from right to left, from left to right, I'm sorry. So we would encounter the methyl at a lower priority number than encountering it this way, where it would be position number 4. So the 1-ethyl means we have an ethyl at position number 1. The 3-methyl means we have a methyl at position 3. And the cyclopentane, meaning we have a cyclic structure of 5 carbons. So this is how you kind of translate naming a straight chain alkane to naming a cyclic alkane.